Hi friends, welcome to GMK tutorials. In this video, we are going to design a asynchronous counter with the help of a T flip-flop. Then we will see the how to write the Verilog code for asynchronous counter with the help of a T flip-flop. Okay, so that is a basic agenda for this video. So previous video, we see the how the synchronous counter we are designing with the help of a T flip-flop, and then we will see the corresponding Verilog code as well as the results analysis also. So let us see in this one. So the credit goes to the the pictorial representation I will take from the source of the internet. Okay, the credit goes to the person who created the diagram. Okay, so it is not my own creation, just I will use the diagram for analysis purpose only. Okay, so thank you for your support guys. We don't know exactly name, so for that purpose I have to mention the credit of the corresponding person. So let us see here. In this asynchronous counter means that generally synchronous means that which performs the. Okay friends, let us see here. This is a diagram for asynchronous counter with the help of a T flip-flops. So basically in case of the synchronous counter, we have to perform the clock signal is applied to all flip-flops at a time. But in case of the asynchronous flip-flops, just we are applying the clock signal for the first flip-flop, then the output of the first flip-flop act as a clock for the second flip-flop, as well as second flip-flop output can be act as a clock for the third flip. This sequence is repeated for the in case of the asynchronous counters. So this is a circuit diagram. Just we have to apply the reset signal for all flip-flops. Okay. So let us see here. Let us see here. This is a circuit diagram for T flip-flop with the help of a D flip-flop. This is a circuit diagram. Just a block diagrammatic represent D flip-flops, and Q is output. Output of the Q, that is nothing but output of the D flip-flop is connected to for the input of the XOR gate, and T is the input for the D flip-flop. The total combination is act as a T flip-flop. So let us consider as per our analysis when Q is equal to 0. Okay, let us see here. Just I will, if it is possible, I will type here. Okay, so let us see the conditions. Where Q is equal to, let us consider Q is equal to 0 and T is equal to 0. So when Q is equal to 0, T is equal to 0 means that when XOR gate is produces only output whenever both inputs are in opposite. Therefore Q is equal to 0, T is equal to 0 means that output is equal to 0. That means which maintains the previous value. So let us consider. Suppose if you are taking T is equal to 1. When T is equal to 1, Q is equal to 0. What happened? It is a 1-0 combination. Therefore output of the XOR gate is equal to 1. That means when T is equal to 1, so let us consider T is equal to 1, output is equal to high. That is nothing but complement of the previous one. That means it acts as a toggle condition. That's why the circuit diagram is act as a T flip-flop. This is the analysis. Okay. Then we will go for the programming point of view. Let us see here. This is the asynchronous flip-flop, asynchronous counter with the help of a T. Let us see the analysis here. Just we will this is very simple guys. Even if you don't have any knowledge on the Verilog, even if you are a beginner, you can write the code for Verilog code for counters or any circuit. Just you will know the concept of the corresponding diagrammatic. That much of very simple coding if you have a knowledge on that one. So let us see here. Module is a keyword for Verilog program. Asynchronous counter is the name, that is nothing but module name I have to prefer for asynchronous counter, and then I have to mention the port list in case just our circuit diagram is in terms of only T flip-flop, right? So T flip-flop input outputs. What are the inputs? So this is one input, clock signal, reset, and output combination only Q. So input outputs can be represented as like Q, clock, reset, and T, right? Then this is generally called as a port list. Port list means which consisting of input and output variables. Then there is a, obviously, uh, even though the system cannot decide what variables that can be treated as an input and output variable. So for that purpose, within the port list, what kind of the variables you are going for use it for input and output purposes. So let us see here output 3 down to 0, right? So here generally Q is nothing but output of the flip flop. So therefore Q can be treated as an output, clock, reset, and T. These three can be treated as the input, because of in case of the T flip flop, we are using a clock signal, clock input combination, and can be treated as a all are can be treated as a. So that is the combinations, right? Then we'll see the code for this one T flip flop. So this is a declaration. So T flip flop, we are using a 4 flip flops, guys. To TFF 1 for the declaration, TFF 0 for flip flop 1. So Q of 0 is output of the first flip flop, clock signal, T and reset. This is very mandatory, guys. For first flip flop compulsory you have to produce the input. As well as in case of the asynchronous counter, obviously we are supplying the input for all flip flops as a one as an input for all flip flops, right? So let us see here in this diagram. So all are connected, T is equal 1 1. That means all flip flops connected to the logic high. Therefore, that can be treated as a 1 for T is equal 1 for all flip flops at the same time. So TFF1 is a module name for this program. Okay, that's why I can mention that TFF1 in this one. Okay, then again TFF1, TFF0 for first one. TFF1 means a unit and a test name for the second flip flop. Q of 1 is output, Q of 0. So it is very easy, guys. Just if you observe this one, first flip flop output is act as a clock for the second one. మనకు ఆల్రెడీ ఆ బేసిక్ నాలెడ్జ్ అందరికీ ఉంది. సో క్యూ ఆఫ్ 0 అవుట్పుట్ క్లాక్ టీ రీసెట్. సో అసింక్రనస్ కాబట్టి ఫస్ట్ ఫ్లిప్ ఫ్లాప్ యొక్క అవుట్పుట్ అనేది సెకండ్ ఫ్లిప్ ఫ్లాప్ కి క్లాక్ లాగా యాక్ట్ చేస్తుంది. కాబట్టి క్యూ ఆఫ్ 1 అనేది ఏంటి, సెకండ్ ఫ్లిప్ ఫ్లాప్ అవుట్పుట్. అండ్ ఈ క్యూ ఆఫ్ 0 అంటే ఏంటంటే అవుట్పుట్ ఆఫ్ ది ఫస్ట్ ఫ్లిప్ ఫ్లాప్ ని యాక్ట్ క్లాక్. సో క్లాక్ ప్లేస్ లో సెకండ్ ఫ్లిప్ ఫ్లాప్ కి క్యూ ఆఫ్ 0 ఇస్తాం. దట్ మీన్స్ ఇట్ యాక్ట్ ఎస్ ఏ క్లాక్ ఫర్ ది సెకండ్ వన్. టీ కామన్, రీసెట్ కామన్. దిస్ ఇస్ అ వెరీ సింపుల్ లాజిక్. సెకండ్ ఫ్లిప్ ఫ్లాప్ లో క్యూ ఆఫ్ 2 అవుట్పుట్ అనుకున్నాం, క్లాక్ ఏమవ్వాలి, ఫస్ట్ ఫ్లిప్ ఫ్లాప్ క్లాక్ వచ్చేసి సెకండ్ వన్ కి క్లాక్ యాక్ట్. సో క్యూ ఆఫ్ 1 ఇస్ ద అవుట్పుట్ ఆఫ్ ది ఫస్ట్ వన్. దిస్ ఇస్ గివెన్ యాజ్ ఎ క్యూ ఆఫ్ 1. T reset command. So Q of 3, Q of 2, T. Just ఒక లైన్ మనము లైక్ డయాగ్నల్ గా లైన్ డ్రా చేస్తే ఎలా వస్తుందో అలా కనెక్ట్ చేసుకుంటే Q of 0 నుంచి Q of 1, Q of 1, Q of 1, Q of 2, Q of 4. So this is a very simple code, guys, for Verilog code for the asynchronous counter. Just if you know the basic concept of the asynchronous counter, definitely you can write a very simple code in terms of the structural model for the corresponding one as well as based on the corresponding language. So let us see, if you are using the TFF1, obviously you have to specify the corresponding code for that one also, then only it will be executed, right? So let us see for the T flip flop, TFF is a name, Q clock T reset. Then output variable Q can be treated as a, so this the same code is already used in the previous one, but except D flip flop. So DFF is a module name, DFF0, Q D clock reset. So this is also nothing but a D flip flop program. ఎందుకంటే మనం D flip flop program యూస్ చేస్తున్నాం. D flip flop కంపల్సరీ D flip flop కోడ్ కూడా కంపల్సరీ ఉండాలి. సో దెన్ వాట్ ఈస్ ద లాజిక్ హియర్, XOR గేట్ యూస్ చేస్తున్నాం కాబట్టి XOR గేట్ అవుట్పుట్ ఆఫ్ ది XOR గేట్ నేను N2 గా అజంప్షన్ తీసుకున్నా. D is the one input, Q and T. ఓకేనా. సో Q, T వచ్చేసి మనకి ఇన్పుట్స్ ఆఫ్ ది XOR గేట్, అవుట్పుట్ కెన్ బి ట్రీటెడ్ as a D అని తీసుకున్నాం అండ్ మోడల్. సో అదే డయాగ్రామ్ మనం అబ్జర్వ్ చేస్తామంటే మీరు ఇక్కడ, సో let us see here. So this Q and T can be act as the input for XOR gate, output can be used as the D flip flop. Okay na? So that's why I can write the XOR gate combination. Then coming to here module d flip flop యూస్ చేస్తున్నాం కదా, ఇక్కడ d flip flop కోడ్ తెలియాలి కదా. సో ఫర్ దట్ పర్పస్ dff q d clock reset. d flip flop obviously ఏముంటాయి, క్లాక్ ఉంటుంది, రీసెట్ ఉంటుంది, d is the input, q is the output. సో బేసిక్ what is the basic criteria of d flip flop? d flip flop వర్కింగ్ ఎలా ఉంటుంది, మనం ఏదైతే ఇన్పుట్ ప్రొవైడ్ చేస్తామో అవుట్పుట్ ఆఫ్ d flip flop కూడా సేమ్ ఉంటుంది. సో ఫర్ దట్ పర్పస్ let us see here for this consideration Q is the output, and this is generally called as a port list, right? All of you have been well known about this one. If you are mentioned the port list, you have to specify the what variables you are treated as the input and output variables. So for that purpose, basically any flip flop consisting of Q can be treated as output. So output Q is equal to Q, then register. Because of if you are using the same variable in the procedural block in the left half of the equation, then you have to specify that variable must be a REG type. So what is REG type? Register variable means that which holds the value for the next update of the corresponding value. Next update every same value hold chesi untundi. So that is it's like a register only, right? Input em chestunam, d clock reset can be treated as an input, right? Then always at positive edge of the reset gaani or negative edge of the clock, ee renditlo ఏ ఒక operation or means that or you can also mention this with a comma also, it is also working. Okay, then if the reset is equal to high, okay, reset value gonna high and em cheyali. So flip flop output q1 is 0 only, so therefore q1 be 0. So where 1 represents the number of bits, okay, b represents the base of the number. Okay, if it is a binary, b can be treated, if it is a decimal, it can be treated as a d, right? Even small b or capital B acceptable. So 0 means that 0, else reset అయ్యగలదు. Then output is equal to ఏమవుతుంది, ఇన్పుట్ ఏదైతే d flip flop ప్రొవైడ్ చేసామో సేమ్ అవుట్పుట్ రావాలి. Therefore output q of the d flip flop is equal to d, that is nothing but input of the flip flop. And module, this is a very basic code guys. If you don't have any knowledge on the Verilog program, మీకు basics ఏమీ రాకపోయినా పర్లేదు, just if you see this program, then definitely you can write the code for a Verilog, right? That much of a simple code. Just to see here how many lines are there, just only you have to write a 7 lines around. Just within the 7 lines you can write the program for the asynchronous counter. Okay, then we will go for the test bench. Test bench ante it obviously what are the input, t ante provide cheyali, t is equal 1 ani ivvali, then what are the combination, just that is enough, right? So reset pin eppudaithe activation avutundo dan mention chestam, based on that the counting operation goes start, right? So for that purpose let us see the asynchronous flip flop. So this is a test bench for this one. Okay, basically remaining all those same asynchronous counter, మన module name ఏదైతే file name యూస్ చేస్తున్నాం previous గా module program కి same మెన్షన్ చేయాలి. Then come to the here test bench name, input declarations, okay, output declaration, UUT name, then initial begin. Let us see here what are the combination t input, ఎందుకంటే compulsory asynchronous flip flop is working only when t is all flip flops inputs are 1 only, then only it performs a toggle operation. Because of it's a t flip flop, reset అనేది high అయితే ఏమవుతుంది, 0 అయితే ఎలా ఉంది, y high 0. Just we will take 4 considerations of the reset, then we will observe the counting operation. Then initial clock is equal 0 అయితే count is clock is equal to not after, అంటే every 10 nanoseconds తర్వాత క్లాక్ అనేది రిపీటెడ్, అంటే పాజిటివ్ నెగిటివ్ అంటే క్లాక్ అనేది రిపీట్ అవుతూ ఉండాలి. సో ఫర్ ద క్లాక్ జనరేషన్ కోసం దీన్ని యూస్ చేస్తున్నాం. సో దిస్ ఇస్ ద programming, right? Then we will see the asynchronous test bench. Already this is over, just we will see the, I think that already we done the program, right? Just we are executing. Let us see this is the output combination. So in this diagram also let us see the analysis, results analysis. Initially the t is equal 1, okay, then flip flop is in working condition. Reset and clock both are in 0 condition. That means obviously what happened, it is in the 0th position, therefore 4 zeros. Because of using the 4 flip flops means 2 power 4, that means the mod of the counter is equal to 2 power n format, right, where n is equal number of flip flops. But in case of our asynchronous counter point of view also, we are taking a 4 flip flops, therefore 2 power 4 is equal to 16, therefore total number of states in the corresponding asynchronous counter is also equal to 16. That is very important guys. So for this consideration, t is equal 0 means ante same memory state, when t is equal 1 ante it acts as a toggle condition. So 0th state 1 every positive edge, okay, so here clock, right? So first positive edge of the clock 1 2 3 4 5 6 7 8 9th state 10th 11th 12th 13th 14th 15. Let us see guys, ఇవన్నీ స్టేట్స్ అనమాట. 0 1 1 7 అని చెప్తాం, అంటే 8th స్టేట్ 1 0 0 8 9 10 11 12 13 14 15. సో 0 నుంచి మొత్తం 15 తీసుకుంటే టోటల్ నెంబర్ ఆఫ్ స్టేట్స్ ఈజ్ ఈక్వల్ 16. దట్ ఈస్ నథింగ్ బట్ విచ్ ఈస్ ఎ కౌంట్ ఫ్రమ్ 0 to 15 స్టేట్స్ ని వరకు కౌంట్ చేసింది బికాస్ ఆఫ్ యూజింగ్ 4 ఫిల్టర్. Again what happens, it is goes for the next 0th state and then the counting operation start. Okay, so let us see here again 0 1. Okay, but you have to observe here very careful, 0th state then 1, after that 0. That means ఇక్కడ 1 తర్వాత 2 రావాలి basically. Then after 1 then we will go for the second state, right? But we are getting a 0. Why? Because let us see here, clock is equal 0 here, then you will come to here, the clock value reset value is high. When the reset value is high means that obviously the counting is going for 0 state. Okay, count is going for 0, negative state of the clock is activated, therefore reset is an active condition and clock is also 0th condition, therefore obviously this is going to be 0, therefore reset is activated, therefore clock is going to be, counting is going to be 0. Then 0 1 2 3, this is the same scenario. So whenever the reset is activated, then the counting operation is going to be 0th state. That means it starts from 0. So this is a very simple analysis for asynchronous counter. If you have any doubts in this one, please contact me. Feel free to contact me. Okay, definitely I will give my best of up to the mark. Okay, so thank you for your support guys, thank you for GMK tutorials up to now. Okay, thanks a lot.